Hey everyone, welcome back to the channel, where we simplify complex software design concept with real-world examples. Today, we are talking about one of the most important and beginner-friendly design patterns, the factory design pattern. It's a game changer when it comes to creating objects in a clean, flexible, and maintainable way. So if you ever found yourself writing too many new keywords in your code, this video is definitely for you. Alright, let's start with basics of factory design pattern. The factory pattern is a creational design pattern, which means it's all about object creation. The main idea is simple. Instead of creating object directly using the new keyword in your code, you let a factory class handle the creation. Think of it like this. Whenever you need a product, you don't build it yourself. You go to factory, place an order, and the factory gives you the finished product. In programming term, this means you ask the factory for an object. The factory decides which class to instantiate, and you get ready to use object without worrying about how it's created. Let's understand this in a simple and a layman term. Imagine you run a logistic company that ships goods by road, air, or sea. Now, without the factory pattern, your code might look something like this. You're calling and deciding object creation based on condition. And if suppose you need this ship object or transport object everywhere, you're going to add this condition, right? So this is one of the example of bad design, right? Because every time you need to write this condition, and if suppose some new transport you need to add, then again it will cause an issue. Now, what happens if you want to add new transport mode like a drone, right? You will have to modify this logic violating the open close principle, which is one of the design solid principle, which says your code should be open for extension but closed for modification. That's where the factory pattern saves the day. Let's fix this issue and move object creation logic directly into factory, which will take care of object creation. And there is no need to write or create object directly into client or calling class. Alright guys, let's refactor this implementation using factory design patterns. So this is one of the bad design practices which we generally follow. But again, right, it is kind of violation of open close principle, which is one of the solid principle, right? Because if suppose you have used this condition across the project, and in future if you want to add any new shipping class, maybe drone, right, then you have to modify this condition everywhere, right? You're breaking open close principle. Better to centralize this logic into a factory, and then client application or maybe wherever you're creating this shipping object dynamically, you can use this factory class, which is centralized factory class. So I have created a refactored version of it. So just to save time, I already kept it ready. So as you can see, initially I was not using any interface. So I have created one interface, right, which is iTransport interface, which is having this deliver method and respecting shipping class, implementing this interface. As you can see, truck class implementing iTransport interface. And just for simplicity, I have simply printing message. But in real world application, it can be complex logic, right? And same for the ship class. I have implemented this interface. Now, to centralized creation logic, I have created one factory class, which is transport factory class. There I have written all my logic to create object, which is taking type as a parameter, and based on type, it is creating respective shipping class object, right? So let's run this. So in main method, I'm simply reading type or transport mode as a input. So let's run this. Just provide truck as a shipping type. So you can see it is calling truck delivery method, right? Delivering by road using truck, right? So again, if you provide input type as a ship, it will run or it will call factory, which is a centralized object creation factory, and it will provide ship object, and then it can call its respective deliver method. So this is how factory design principle solve the problem. Instead of writing this object creation logic everywhere using new keyword, you can create one centralized factory class, and at runtime, based on type, or maybe based on environment variable, or maybe based on dependency injection, you can call this factory class, which will again provide a respective object. Okay, so this is how we implement factory design patterns. Now let's explore some use cases, real world use cases of factory design patterns. You can see the factory patterns used everywhere. For example, in database drivers, you call DB provider factory.createConnection class and it returns the correct connection object depending on your database type, right? In UI framework, different button types are created using factories to match the platform like Windows, Mac, or web. Another use case is in payment system, right? You can create the right payment gateway object without changing your main business logic like PayPal, Stripe. Now let's move to QA section. Now one question definitely coming to your mind: if the factory class is creating all object, doesn't it become centralized? Should we make it singleton? The short answer is not necessarily, right? While it's true that factory centralized the object creation logic, that doesn't mean it should be singleton. A singleton ensures only one instance of a class exists throughout the app, like single shared database connection or logger. A factory, on the other hand, is about decoupling object creation logic, right? Not limiting instances. However, if your factory doesn't need any specific data and just provide static method, you can make it static or singleton for convenience. In short, singleton controls how many instances exist. Factory controls how objects are created and what type is returned. Now the second question, which generally asked, right? Can the factory pattern violate the open close principle if we keep modifying it? Technically, if you keep adding new if else or switch statement inside your factory every time you add a new product, yes, it could start to violate the open close principle. But the idea is to design the factory so it can be extended without modification. For example, by using reflection to load types dynamically or using dependency injections where new factories can be registered. So the pattern itself doesn't break solid, only a poor implementation might. Now another question is, when should I use factory versus when I should use new keyword? You should use the factory pattern when object creation logic is complex. So you should use factory pattern when object creation logic is complex or dynamic. Second, you might change implementation frequently. And the third, you want to hide concrete classes from the client. Or when your code should be easily testable using mocks. So if you are creating simple object like new user, you don't need a factory. But if your system needs to create different payment processor object depending on the configuration or environment variable, that's a perfect use case for factory design pattern. Another question, can we use dependency injection with factory pattern? You can use DI containers like AutoFac, Unity, or .NET Core inbuilt IOC containers and let the container handle the object creation behind the scene. That way your factory can focus on business logic while the DI containers manages dependencies and life cycles. So remember, design patterns are not rigid rules. They are guidelines to help you write clean, maintainable, and scalable code. And the factory pattern is one of the best starting point to understand that philosophy. So if you have got more questions, drop them in the comments. I might answer your question in the next video. So in conclusion, the factory design patterns help you centralized object creation logic. It follows the open close principle from Solid. It make your code more flexible, scalable, and maintainable. It's one of those patterns that you will find yourself using again and again, especially in enterprise and microservice architecture. That's it for today's episode on factory design patterns. If you found this helpful, don't forget to like, subscribe, and share this with your fellow developers. In next video session, we will cover abstract factory design pattern, which is one of the creational design patterns. Until next time, keep coding smart, not hard. Thank you and goodbye.